With parallel and perpendicular lines, we want to understand what they are and what we know about them mathematically. We'll start with parallel lines. Parallel lines are lines that never intersect. So here's a pretty good picture of two parallel lines. We can also see by looking at these that it looks like they're growing or shrinking, if shrinking is the right word. Looks like they're increasing or decreasing at the same rate as each other, which means that their slopes would be the same. So if this one is M1 and this one is M2, then it would be reasonable to say that M1 is equal to M2. Same slope. M1 equals M2. These are parallel. If we look at perpendicular lines, on the other hand, not what I meant to do. A line and a line. Let's get this as close to just right as we can. All right. Let's say this one has slope M1. This other one has slope M2. Perpendicular lines intersect at a 90-degree angle. So they do intersect, and their slopes have a little bit more complicated relationship. We can probably see by looking at these lines that if one has a positive slope, the other should have a negative slope. We can also perhaps see that if we tried to make one of them steeper, the other one would get compensatingly less steep. And because of that, when the rise increases relative to the run in one of the lines, the run has to increase relative to the rise in the other line. And so those two characteristics that we just described, we can say with their slopes, a very common way of expressing this is to say that the product of the slopes is equal to -1. But if we were to solve that for M2, that would look like this. M2 is equal to -1 over M1, which we can then describe in words. And describing this in words, I think, is the easiest way to understand it. This tells us that to get from one slope to a perpendicular slope, we have to change the sign. It has the opposite sign. And this tells us that we have to take the reciprocal or flip it over. This is the relationship between perpendicular lines. In particular, the relationship between the slopes of perpendicular lines. It's entirely determined by their slopes. So, for example, if we know that the slope of one line is -3/5 and we want to know the slope of a perpendicular line, we would change negative to positive and we would flip over the fraction. So flipping that gets us 5/3. Since the original has a negative slope, we know that our perpendicular line has a positive slope. If we know a line has slope 2, we can think of that 2 as being a 2/1, so that we have something to flip over. We certainly don't want to just flip over 2 and get an upside down 2. That's not a number, right? So because our original slope was positive, this one will be negative, and we'll say that this slope is -1/2. So lines with slope 2 and with slope -1/2 are perpendicular. We can use that information to help us find an equation of a perpendicular line given an equation of another line, right, of the line that it's perpendicular to. So what we want to do here is identify our point x1, y1. This is constants, right? I just said 1 and I wrote 2. x1, y1, which is a point on the line, and we want to be perpendicular to the line y equals 1/3 x minus 2. The only piece of information that I'm going to take from this other line is its slope. So this line had slope 1/3. Our line has got a perpendicular slope. We'll just call this slope m. It's going to be -3/1, which is just -3. Now, what we need to remember when we're doing a problem like this is that we don't really care what the y-intercept was of the line that we were given. Sometimes we feel so attached to the information that we have, or maybe we had to work for it, like we had to solve this for y and get it into the form y equals mx plus b. We can end up feeling so attached to that information that we're inclined to try to use it. The y-intercept of the line that we are perpendicular to is not relevant to anything, only its slope. So we take the slope, right? We're going to take this slope, we're going to take this point, and we're just going to start over making our own equation. So I look at these pieces of information. The first thing I ask myself is, do I know the y-intercept? If I know the y-intercept, I go straight to y equals mx plus b. If I don't, as is the case here, I have to start with the slower one, right? The point slope form. Plugging into this gives me y minus -2 equals, my slope is -3, and x minus -1. Now I'm just going to simplify these signs. Y plus 2 equals -3 times x plus 1. Then distribute into the parentheses. And finally subtract off 2. This gets me a slope-intercept equation. Now, of course, I read my instructions again and realize that it wasn't really necessary. Either this form or this form would be fine. This is the point-slope form. I certainly wouldn't leave it with the subtractions of negatives. That form is a little bit sloppy. But given that we weren't specifically asked for a slope-intercept equation, either of these is okay. This one would be the slope-intercept equation if ever you're asked for that on homework or tests or something. But this is also an equation of the line. It's one of the many point-slope equations of this line. But both of them are equations of the line.